So in today's video, we're going to talk about writing pattern rules and patterns within mathematics. So what is a pattern? So let's start there. So what is a pattern? A pattern is a group of numbers, shapes, or objects that follow a rule while repeating or changing. So let me give you an example. Let's look at that. So if I was to have a pattern of numbers, it could be 2, 4, 6, 8, and 10. And you see there's a pattern. In this case, the pattern is changing. It's not repeating. And again, the pattern is increasing by 2 each time as we go through it. Okay, so the pattern is changing as it increases by 2. So there's a pattern that is changing. And then if we had a pattern that was repeating, so let's just erase that out. So a repeating pattern might be something similar to this. So we might have a 1, 2, 3, and then again 1, 2, 3, and in this case the pattern is repeating as it goes through the pattern. The pattern might be a pattern of numbers. It could be a pattern of objects, so it doesn't necessarily have to be numbers, and in class we've looked at different objects that are within the pattern, so it could be a pattern of different shapes, and again it could be a repeating pattern. And in this case, I've just drawn triangles and squares. The pattern can vary. So a pattern is whenever you have either a group of numbers or shapes or objects that are following a rule of either repeating or changing. So what is a pattern rule? Let's talk about that. So a pattern rule, is a rule that the pattern follows as it repeats or changes. So whatever the rule is, so if it's repeating, it might be like we showed the shapes. It goes from a triangle to a square, triangle to a square. So the rule is that after a triangle comes a square, and then a triangle again, in that case. In the rule for when we did the 2, 4, 6, 8, in this one, the rule is the pattern is increasing by 2. So I'm adding 2 each time to increase as I go through. So this is a pattern that I'm showing. So it's a repeating rule, and the rule is it's adding 2 each time. Now, in class we talked about what a term number was. And so if I take this same pattern, and I'm going to show it to you in a T-chart now, and we're going to look at it that way. So if I put this in a T-chart, I have my 2, 4, 6, and it keeps going. And I put term numbers, 1, 2, 3, 4. All the term number does is it labels which one comes first. So the first number is 2, the second number is 4, the third number is 6, the fourth number is 8, and that can keep going. So when we looked at it in this form, the term number simply says this is the first number that comes, the second number, the third number, and the fourth number. So here we're going to say term number, and it just tells us the position of the item in the pattern, and in this case the item in the pattern are values. They are numbers, so they're values. So item number, value number 4 is the second term. So value number 4 is the second term in my pattern. Value number 8 is the fourth term in my pattern. This is going to be important to you when we get to writing an expression using this chart. So this is an introduction into what is a pattern, and we're going to move on from here. So we're going to talk about 3 different types of pattern rule. One is a recursive pattern rule, an explicit pattern rule, and a common pattern rule. So the first one is a recursive one. So what is it? It's a pattern rule that tells you where you start, the start number of the pattern, and how the pattern continues. So if I give you a pattern, I'm going to give you the pattern 5, 8, 11, and 14, and you can continue the pattern onwards. And so I look at this pattern, I go, how is this pattern increasing? Okay, it's increasing by 3. I can see that by looking at the pattern each time I am adding 3. So in this case, I might say that my pattern starts at, start with 5, and what am I doing to the 5? I'm adding 3 each time. Add 3. So this is a recursive pattern rule. So it just tells me what I'm doing as I go through the pattern. A pretty simple way of putting it. The next one we're going to look at is an an explicit pattern rule, and this pattern rule tells us the term number and then tells us how the pattern is changing using the term number. So this is what we've done on the previous page where we did the t-chart. So I might draw a t-chart. Let's say I have a pattern, I have my term, and then I have my value. And again, I'm just going to use the same one that I used on the previous page. I have 1, 2, 3, 4. I have 2, 4, 6, 8. So each time the pattern is increasing, we're adding 2. But what's happening to the term number to get to the 2? So this term number 1 times the 2 is giving me the value, which is right there. And I can just keep going. So I know that if I do 2 times 2, it's going to give me the value 4. So in this case, it is my term number. This is my term number multiplied by 2 gives me my value. My term number 2 multiplied by 2 gives me my value. So in this case, I would say so when we're giving this rule, we're saying term number multiplied by, and in this case we said we're multiplying the term number by 2. So that's my rule. And then we're going to the next one, and this is a common difference. And the common difference is the difference between the 2 consecutive terms in the pattern. And so let's again give you a pattern that we're looking at. So if we're looking at the pattern 3, 11, sorry, not 3, 11. Let's do something else. 3, 7, 11, and 15. I might say what's happening between the 2 consecutive numbers. So I go, let's see. So I say 15 minus 11 equals 4. Okay, so I know 4 is, it's going backwards to, there's a difference of 4. And then I go, let's try 11 minus 7. What do I get? So the recursive pattern is, the common difference, the difference between the 2 consecutive numbers is a 4. So all I did was I found the difference. So again, speaking in math terms, when we're looking at difference, we're looking at subtraction. So each time we're looking at difference, we're thinking about subtraction. And so we're just finding this difference between the 2 numbers. And again, if we do 7 minus 3, we'll get the same thing, we'll get 4. So that's the common difference. So what is a variable? A variable is a quantity that varies or changes. A variable is often represented by a letter or symbol. So in class, we've been looking at variable as represented by n. So every time we have a variable, we're saying that we're just going to call it n. So the example that I gave you on the previous screen, we said term is where the number is in its place. So the term represents what place it holds. And then we have our values. And we have each value, we said, let's just do 2, 4, sorry, I'm just going to erase that. 2, 4, 6, 8, and we knew it was increasing by 2 each time. And so in order to form an expression, which is the next one we're looking at, in order to form an expression, a mathematical statement made with numbers and variables, we need to know what our constant is. So what is remaining the same? So in this case, if we look here, we're realizing that our constant is the 2. The 2 remains the same. That's going to be my constant in my expression. My variable is something I can determine. So my variable is a number that changes. So the number that changes here is my term number, is going to be my variable. And we're going to be looking for the value of the expression. So when forming an expression, in this case, I know that my value is the answer that I'm looking for. Okay? My constant is the 2. It doesn't change. My n is my term. And I know that each time I multiply my n by the number 2, I'm going to get my variable. And you can check that. So if I was to do a check, I'd say if n equals 4. So again, my expression is n times 2 equals v. So I say in the value of my n, I'm going to put a 4 times 2 equals v. And I know that when I multiply my 4 times 2, I get the answer 8. And I say, okay, so is this answer the same as here? Yes, it is. So whenever I use the 4, I get an 8. That tells me my expression is correct. And so now, again, your variable is something that you can input in order to find your value. So we've talked about a bunch of ideas. We're going to try to put those ideas into practice now. So here is a question that I'm giving you. So Sahil learns that a year on Venus is about 7 Earth months long. And so what I've done is I've started to create a table. I'm going to ask you to pause the video, go through each of the questions that I have here on the screen and try them out. And then I'm going to go through them really quickly with you. Okay, so go ahead and pause. Okay, welcome back. And so if you've started to do this question, you realize that all I'm asking you to do is go ahead, and I've started the table here. And so here is the table, and I said, here are my term numbers. This is the number of years on Venus. So this is my term. This is my value. This term is each of the years on Venus. And so in 1 year on Venus, we've learned that 1 year on Venus is 7 Earth months. So my first value is going to be a 7. And then as you went down that chart, you were able to fill it in. And so I'm going to go ahead and do that. I'm going to fill in some of it. I'm going to leave some of it blank. All you're doing is you're just going, okay, so we know 1 year is 7. I am adding another 7 to that, and I'm going through the list. And I'm adding 7, and you can keep going. Okay, so I wanted you to go up to 8. I wanted you to keep going. I'm not going to show you all of it there. So now my next thing is come up with a pattern rule. What's my pattern rule? What is happening? So the pattern rule we are going to be talking about is the explicit pattern rule, which tells me what's happening to my term number. So in this case, I'm just going to type in there, I'm saying that my term is what's happening to the term number each time to help me increase it. You notice that if the term number is 1 and my value is 7, my term number is being, so you're multiplying the term number by 7 to find the value. Okay, so you're multiplying the term number by 7 to find the value each time. So that is my pattern rule. Once I have a pattern rule, I go ahead and I try to find out I use my pattern rule to write an expression. So I think to myself, what is my variable? Let's call my variable, in this case, we're looking at number of years on Venus. You can use the n if you want. You can use a y for years. You can use a different variable. It doesn't have to be the same one we've always used. So I'm just going to say n. What is happening to the n? I set up here that my term number, which is the n, this is my term number, is being multiplied by 7. So I'm simply writing that is being multiplied by 7. And when I do that, I will find, and if you look here, find my value. So I came up with an expression. Now, in order to check if my expression is correct, I'm going to do a check. So it says, do a check using the third term. So I look here, and I say the third term. The answer to the third term is 21. So I'm going to go ahead and check to make sure I'm correct here. So I say, I'm going to type in when n equals 3. So n times 7 equals v. 3 times 7 equals v. And when I multiply 3 times 7, I end up with 21 equals v. So I know it's correct. My expression is correct. So then I go ahead and I solve. It says here, use your expression to calculate the approximate for 12 years. So I say when n equals 12, and I'm going to go ahead and do the same thing. So n times 7 equals v. 12 times 7 equals v, and the solution is going to tell me that it is 84 equals v. So there you go, you went through the entire process. Now I'm going to leave you with a question. Your task is to solve this. Again, it's the same thing that we just did on the previous screen, just with a different question. This time it says, Colleen saves $12 each month from his newspaper route. You're creating a table of values up to 8. You're using your table to write a pattern rule. Okay, so you're writing that pattern rule. You're writing the explicit pattern rule, so you're telling me what happens to the term number. You're using that pattern rule to write your expression. Then you are checking your expression for the 6th month. Then you're using your expression to find out what's going to happen, how much money he has saved for the 18th month. And then I threw in a multiplication or a division or a something question here, which is going to test your number sense and numeration right over here. So you're going to bring this back to class with you tomorrow, on Monday, and we'll talk about it then.